Hello, and welcome back to Political Science 4781, Techniques of Political Analysis, Visualizing and Interpreting Data. And today we're going to talk a bit more about R. And a lot of the stuff that we're going to talk about today is sort of fundamentals of how to do some straightforward things in R, importing data, for example. We'll talk about object classes. And when you pull information into R, or you add information as an object, R assumes that the object has a certain class designation. That is, it could be a number, it could be a matrix, it could be a data frame, something along those lines. And it can be useful to understand what R understands as an object class, because sometimes it's necessary or desirable to change it. We're going to talk about how to reference part of an object, how you're going to look at just one variable out of a data frame, for example, or one observation in a data frame. We'll also look at subsetting objects, pulling smaller subsets of data out of a larger data frame. We'll go over naming and renaming the rows and columns, merging data frames, that is, combining multiple data frames into a single one. Exchanging rows and columns, that is, if the rows and the columns need to be transposed, there's a straightforward way to do that. And then finally we'll talk about summarizing data. Now, one of the first things that you're going to need to understand how to do is import data, because you're going to want to be pulling a lot of data sets off of your computer and into R's memory. And the first thing you need to know how to do in order to do that is to set the working directory. That is, point R toward the directory in which your data are located. In this case, all I've done is put the data set that I'm interested in on my desktop. So what I'm doing with the setwd command is telling R to go to my desktop and execute the next commands there. Now you could also do this under the MISC menu with the choose a new working directory command. Works either way. Now, what we're going to do is use the read.csv command to read this file, testscores.csv, which exists, and we can see it in comma-separated value format. Right? It looks something like this. Or if you open it in a different program that's better at showing off, I'm zooming by here, showing you what it looks like just with text and commas. Okay, so we're going to point R toward testscores.csv. We're going to use the read.csv command, which understands how to read in comma-separated value files, and we're going to store that in this object called scores. Okay. Now, once we've done that, we can examine the object just by typing in its name, and R will tell us, okay, here are test scores for Smith, Jones, and Brown. Well, it doesn't tell us their test scores, but we know their test scores. Smith got an 88 on the first test, a 91 on the second test, and so on and so forth. Okay. Now, one thing that's useful to know is what can be useful sometimes. It can be very useful if you run into problems with calculations, is what the object class of a particular object is. And if we look here and type in class scores, it'll tell us you're looking at something called a data frame. The only reason that this really matters is that sometimes you can't carry out the kinds of commands you want to carry out on a particular object, as I'll mention in just a minute. So if we want to transform the data frame called scores into something else like a matrix or a list, all we need to do is type in as.matrix scores, and that'll produce a matrix which looks a whole lot like a data frame. As list, and it'll give us a list of the test scores by name, and so on and so forth. So I said just a moment ago, sometimes you can't carry out some actions on some classes. What do I mean by that? Well, I'm going to show you. I'm going to create an object called x and an object called y. I'm going to give x a value of 5, and I'm going to give y a value of 3, and I'm going to use R as a very, very high-powered hand calculator. And I'm going to add x and y together, and it's going to tell me x plus y equals 8, because x is 5 and y is 3. That's fantastic. But when we create an object called z, which is a character version of of x, and we take a look at z, R tells us, z is equal to 5, but 5 with quotes around it, because we've turned this number into a character, into text, basically. And what that means is that R no longer understands that that has a value of 5. It thinks it's the character representation of 5. Now, that may seem like a very subtle difference to you and me, but when you try to add z and y together, it says one of these things isn't a number. You can't add these two things together, right? So sometimes it becomes important because R doesn't always understand perfectly when you import an object what that object's class should be. So it's generally a good idea to take a look at the class and see whether you're going to be able to do what you want to do with it. Now, we've got our list of scores in, our list of test scores. And one of the things that you might want to do with this list of scores is just to reference part of it. And for that reason, indexing becomes really, really handy. There are a few different ways to index part of a data frame or part of a matrix. One way that you can do it is by using these square brackets and entering either the index number, if you're looking at a series of numbers, or in this case, the row followed by the column, separated by a comma. Now, it doesn't look here as though I've got the row followed by a comma followed by the column, because there's no row listed. Well, what that means is I want all the rows. I want you to give me the numbers in all the rows. So when we enter this gives us the scores for Smith, 88, 91, 75, 84. Okay, that gives us all of the entries in all of the rows for column 1. Now, in the same way, you could just tell it to give you all of the rows that are associated with the column named Smith. Now, since Smith since that's the only column named Smith, that's a unique identifier, and again, you'll get all the rows associated with that column name. The third way to do it, which is also equivalent to the first way, is to use a $sign. So scores $Smith, what that says is within the scores data frame, there is a variable called Smith, and I want you to list that variable for me. And when you ask it to list that variable for you, you get exactly the output that you would expect. So there are a bunch of different ways to look at subsets of data frames, in particular when the subset is one or more variables. Now, what if we want to look at just a row instead of a column? Well, we put row number 1 in here, and we tell it to give us all columns by leaving out any column designator at all. So when we do that, it says, all right, on test number 1, which is row number 1, Smith got an 88, Jones got a 73, Brown got a 92. Now we can combine these two ways of indexing things by using both of the spaces inside the square brackets here. That if we want to look at Jones's score on test number 3, the tests are the rows, the columns are the students. So we're going to look at row number 3, which is test number 3, and column number 2, which is Jones, and that will give us Jones's score, as you can see right up here. Right, Jones's score on test number 3. You can also, as before, tell it to give you the score for test number 3 for the column named Jones, or you can type in scores $Jones, that is, give me all of the scores associated with Jones except in this bracket without any commas at all, you're saying, actually, I just want element number 3 of that list. I only want the third item in the matrix. So up here, where you type in scores $Smith, it gives you this list, right, of 4 different scores. Well, what you're telling it here, scores $Jones, square bracket 3, is I only want the third value on that list. Okay, so when we enter that, again, we get Jones's 88. So knowing how to index objects gives us some idea of how we can subset them. That is, how we can break bigger objects down into smaller ones. In this case, we might only want Smith's scores, or we might only want the scores for Jones and Brown. Well, how do we go about doing that? It's pretty straightforward. All you do is combine your indexing commands over here with the assignment operator, this left-pointing arrow, and you create a new object called Smith scores here, in this case, which is going to be the first column of our scores data frame. And if we examine Smith scores, we see that, in fact, it only has the scores for Smith. If we want to create an object with both Jones and Brown's scores, we tell it to produce Jones.Brown.scores, which is columns 2 and 3 of the scores database. And when we look at that, it in fact gives us columns 2 and 3 of the data frame that had all the test scores in it. Equivalently, again, you could create a new object telling R that you want only the scores for Jones and Brown. You have to use C here to concatenate Jones and Brown. What that does is it tells R you're giving it a list of names. So once you've given it the list of variable names, and you take a look at what it gives you, it says, all right, it goes to the columns, and it says, I'm going to find the column named Jones and the column named Brown, or the variable named Jones and the variable named Brown, and I'm going to put them together into a single data set. So that's relatively straightforward. In this instance, you've already got, in this example, you've already got names for the columns. But what would happen if you didn't? Well, it's pretty straightforward. What happens if you don't give the columns names is that R gives them some boring name for you. I think it's V1, V2, or X1, X2, something like that, or it just doesn't name them at all. So what happens? How do you go about fixing that? So here you've got the colnames command, and colnames allows you to take a list of names. In this case, we're gonna take Smith, Jones, and Brown's first names, which are Lisa, Janet, and Sally, and we're going to put those first names in as the column names rather than their last names. Okay. So now, instead of Smith, Jones, and Brown, we have Lisa, Janet, and Sally. If that's a little too confusing, if it's easier to keep track of both, we can put in Lisa Smith, Janet Jones, Sally Brown. And when we look at scores, again, we will see the column names are Smith, Lisa, Jones, Janet, Brown, Sally. And if we want, we can use row names, which works exactly the same way as column names does, to produce names for the rows. So here we've named the rows. Instead of just numbering the rows 1, 2, 3, 4, as R usually does, you get test 1, test 2, test 3, test 4. Okay. So again, that should be fairly straightforward. And it helps you to be able to reference the individual items inside the object. How about merging? Let's say that we've left off the test scores for Joseph Green, but we have them in a separate file. So first we're going to read those in. We're going to take a look at the second. We're going to read those into a second object called scores2. sorry, we have them online in a file called testscores2.csv on the hard drive. So we read these in, and we look and we see we've got Joe's scores. What we don't have, the header looks a little bit odd. The column name looks a little bit odd, but we can fix that. Something about the way that it reads in columns is a little bit quirky. So now we've got the test scores for Green as well as Smith, Jones, and Brown. Here we run into a problem. We can't, when you merge two data sets, when you merge two data frames, you need to match the observations. So, for example, if you were looking at population and GDP for all the countries in the world over a range of years, and you had population in one file and GDP in the other, and you wanted to combine them, but the rows weren't necessarily in the same order, what you would have to tell R is, I want you to match these observations by country and by year, because I don't want, Venezuela's population combined with Uruguay's GDP, right? So when you tell it to match by a particular variable, what you're telling it is, if the other variables have this in common, then they belong on the same line. So here what we want to do is match by test number. So we need to create in both the scores variable, the scores data frame and the scores2 data frame, a new variable for test number, as we're doing here. So as you can see, in both scores and scores2, we have a new variable that we created that is just test number 1, 2, 3, 4. This colon saves you a lot of time. It lets you say I want a sequence of numbers from 1 to 4, or from 30 to 50, or from 30 to 12. It'll count backward if you want. Okay, so now that we've got test number in both of our data frames, we can merge matching on test number. So the syntax here is you merge, here's the data frame number, the first data frame's name, here's the second data frame's name, here is the name of the variable in the first data frame that you're matching on, here is the name of the variable in the second data frame that you're matching on. These don't have to be the same. They have to be whatever the variable is called in each of those two data frames. So if you're matching on year, and year is called year in one data frame and YR in the other data frame, then you would put both those, year and YR, in the by X and the by Y specifications. So we go ahead, we merge into our grade book, and the result looks something like this. For test number 1, Smith got an 88, Jones got a 73, Brown got a 92, Green got a 68. If this is not the way that you want to look at this information, there's a very simple command, T, which stands for transpose, that allows you to flip the rows and the columns. So if you just do that, you can read down the rows and say, all right, Smith got an 88 on test number 1, a 91 on test number 2, and so on and so forth. This can be very handy if the data that you get are not in the right format, if the variables are in rows rather than columns, and you want to change that. Now, finally, I want to talk briefly about how to summarize data. A lot of times what you want is just, in this case, average test scores. So let's take a look at the average test scores using colmeans, which calculates the mean of each of the columns, as the name might imply. And what that does when you say colmeans for the gradebook data frame, columns 2 through 5, remember we don't need the average for test number, that shows you that Lisa Smith's test average is 84.5, Janet Jones is 82, Sally Brown's is 91.5, and Joe Green 77.75. You can also take a look, if you want, at the averages on each test. And in this case, you would do that by looking at the row means, the averages across the rows. So this tells you an 88, a 73, a 92, and a 68 average out to 80.25. And if you want a full summary, you can use the summary command, which gives you not just the mean, but the median, the quartiles, the minimum, and the maximum. It gives you a lot of information about every one of the columns or variables.